Okay, sorry, we just cut out again. What did you say now?
So they would like pass that to say that it's immediate and altitude.
Yeah, you can conclude it.
Thank you.
Okay. Now in question C says, determine the equation of AC. Determine the equation of AC. So basically AC is a straight line, so the equation of a straight line will be in the form of y is equal to mx plus c. To work out m, which is your gradient, is y2 minus y1 over x2 minus x1. So for AC it's going to be 2 minus minus 2 over 5 minus minus 7. So it will be 4 over 12, which is, no, I didn't have to calculate the gradient of AC. Why? You already have it. So what's the gradient of AC? A third. So y is equal to a third x plus c. And you'll substitute one of the points. Let's go with c, which is 5 and 2. So x and a y. So 2 is equal to a third times 5 plus c. So c is 6 minus 5 over 3. It's going to be a third. Is that correct? So y is equal to a third x plus a third. We're looking at D. In D, the question says, prove analytically that AB is equal to BC. So AB is equal to BC. So what do we do there? Distance formula. So AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So for B, AB, so to be negative 3 minus 7, which is plus 7 squared, plus 6 minus minus 2, so 6 plus 2 squared. Okay, so that's going to be 4 squared plus 8 squared, which is 100, which is 10. Is 10 correct? 4 squared plus, actually 6 squared plus 8 squared is the root of that is 10. That's 4 root 5, is that correct?
Yes.
4 root 5. And then we go with BC. Same formula, which is the distance formula. It's going to be minus 3 minus 5 squared plus 6 minus 2 squared. That gives us the square root of 8 squared plus 4 squared. So also 4 root 5. Okay, and then therefore, in conclusion, we can conclude therefore BC is equal to AB, which is equal to 4 root 5. Okay? Now coming to the question that was asked, the question says, if F is a point, a negative 9 in P, determine the value of P if AF is perpendicular to AC. If lines are perpendicular, what do we know? Product of the two gradients is minus 1. Not so. So the gradient of AC we know, which is what? A third. So the gradient of AF is equal to negative 3. Not so. But we know that, or we can say that you go change it by changing x. So it's going to be P minus minus 2 over negative 9 minus minus 7. So that in terms of P, it's going to be P plus 2 over negative 2. We all agree with that? So we know the gradient of AC times the gradient of AF is equal to negative 1. So it's a third times AF, which is P plus 2 over negative 2 is equal to negative 1. So what do I do at this point? I divide it by a third both sides. Okay? With that now cancelled, so p plus 2 over negative 2 is equal to negative 3. That is naturally over 1 and cross multiply. So that will give us p plus 2 is equal to 6. So p is equal to, okay, the common asked question. It either says they are perpendicular or they will say they are parallel. If it was parallel, what would I have done different? The gradient of AF would have been equal to the gradient of AC. What if they told us that points E, F and G, they give you the coordinates of G. Or they tell you, E, F and G, GAF or collinear, they give the coordinates of G as well. Then I would have set the two gradients equal to each other, right? So points are collinear, gradients are equal. That's number 6. You can know any issues number 7? Number 8. Number 9. Number 10. Issue number 10. Number 11. Huh? Alright, so that basically brings us to the end of. Okay, so I'm going to do number 11. Although none of you had a problem with it. So it will be for the benefit of the next group that's coming through. Hopefully they will do their work, not like you people. Yes? It's coming in your term 4 cycle test and your exam. Why you want me to let it come in this exam? This is easy, fairly easy. Now I'm just saying this is fairly simple. Is this the work difficult? You haven't written a test on it yet. So you haven't written a test on it. But once you do it, you'll see it is simple. Not so difficult. Right, so we're looking at number 11. In number 11 we are told that A, which is 2 and 7, B, which is 8 and 4, C, which is 5 and P, and D are the vertices of quadrilateral A, B, C, D. Then we are told that E is negative 1 and 1 is the midpoint. Now the midpoint is given now. Okay? The midpoint is given. The first question says determine the coordinates of D. Right? As you can see, the midpoint is given there. So we're going to use the midpoint formula. This is number 11, eh? Okay. I ask you to work out the coordinates of D. So let's make D X and Y for now. Then we know that for the midpoint, it's normally x1 plus x2 over 2, y1 plus y2 over 2. Then that end up giving us the coordinates of the midpoint, which is x mid, y mid. So with that in mind, we know that x1 plus x2 over 2 gives us the x midpoint, and y1 plus y2 over 2 gives us the y midpoint. So it's going to be 2 plus x over 2 is equal to the x mid, which is negative 1. And then 7 plus y over 2 is going to give you the y coordinate, which is 1. So naturally let's have a 1 across multiply, so 2 plus x equal to negative 2, x is negative 4. And then here we cross multiply, so 7 plus y is equal to 2, so y is equal to 5. So therefore the coordinates of D is negative 4 and 5. Okay. Yes? And negative 5, absolutely. And just realize now, both have to be negative.